guys, so welcome to the Cybersecurity Threat Intelligence Researcher certification. This is going to be a really exciting certification because if you want to know, for example, that your company was compromised and you want to know exactly who attacked the company, who is behind this, what is the specific threat group, the nation where they are connecting to, the techniques being used by them, this is exactly the kind of skills that you need, okay? So we're gonna be teaching you how you can get a piece of malware and from there, go all the way up to the nation and the threat actor location so that you can even take down the organized crime via laws enforcement joint effort, okay? So this is the first course. We're gonna be talking about the different phases. It's gonna be just an overview. And then we're going to start going by any specific step in detail. My name is Daniel Regalado. I am the lead author of Grey Hat Hacking Book 4th edition, and I hope you enjoy it. Okay, so this is the agenda. We're going to be talking about the different phases, as I said. The first phase is hunting. Don't worry about that so far. I'm going to be talking in detail. Then second phase is features extraction, behavior extraction, clustering and correlation, threat actor attribution, which is basically deciding who is behind the whole operation, tracking and taking down, okay? So let's talk about the different phases. The threat intelligence researcher goal is identify and track threat actors. As I said, at the end of this whole effort, you should be able to know who is behind. Is North Korea behind? Is China behind? Is a nation state sponsored effort where they are locating from? Those different details is what we need to get by doing this specific effort. Helps to be more proactive instead of reactive. And the reason is that if you understand how this specific threat group operates, you might be able to hunt for more samples or malicious software related to that group, and therefore you can find new samples in internet, add protections against them, and then you can protect your organization proactively. Broader detection, as I said, because you can find more samples from this specific gang. And full picture of the attack. This is very important because nowadays when you get a piece of malware, you can ask the reverse engineer to get all the details, right? And you can see that, okay, this is a malware that is doing some connection to internet, exfiltrating some specific data, and they are probably stealing the credentials from the box, which is fine, but that doesn't tell you anything about who is behind the attack, right? So with these skills, you need to be able to understand from that specific sample where it is connecting, what it is being exfiltrating, the techniques being used to do that, and at the end of the day, who is behind the whole operation. The full picture is going to be understood. And finally, the gang or the threat actors can be dismantled, which means that you can work with the FBI, the law enforcement, even international like Europol or Interpol, so that you can, with them, go and physically arrest the bad guys, which is at the end of the day what we want in order to stop operations from the organized crime. Okay, so here is just an example so that you know what I'm talking about, like Microsoft teaming up with FBI to take down the Game Over Zeus botnet, which was, is actually pretty active botnet. But you can see that organizations like Microsoft, they do their intelligence, provide that intelligence to FBI so that together can go and shut down the servers and physically arrest the people behind. Okay, so here is what it is, the threat intelligence in a glimpse. I'm going to give you a quick step through all the different processes. The first step is called hunting, which basically, before starting doing anything, you need to have samples. You need to have malicious software so that you can start trying to understand what it is doing. That's the first step, and therefore you need skills to know how to hunt for those specific malicious software in internet. Okay? The second step is once you have the hunting, now you need to extract features. We're going to talk about what are those features, which are static features. Okay? Once you have the features, you need to extract the behavior, what it is doing. It is downloading from internet, it is stealing your credentials from the box. You need to extract also those features, which is called dynamic extraction. Once you have these features, this behavior, then you are going to cluster in groups for specific families based on that information, and then we'll correlate all those different information in order to have a better understanding of the attack flow. Once you have that, you can start thinking about attribution. It's a very important step, which means who is behind this malicious operation. Once you have all that, you identify the threat actor. It is important to track him, to know what he is doing when he is releasing new malware to the victims, when he is opening a new C2 or CNC server, which is the server where they are connecting to send the malicious information or to control the infected victims. You need to be able to track it properly. And finally, the takedown. As I said, you need to be able at the end to provide all information if needed by the law enforcement so that they can go and shut down the server and even physically arrest the bad guys. Okay, so let's talk a little bit about those different phases. Not in detail, I'm going to have a specific class for those different sections, but now I'm going to give you a quick overview, okay? So the first one is hunting. Our goal is a technique to collect samples from different sources that helps to start profiling the malicious threat actors. We need to gather samples from different sources, and we're going to see which are those sources. Okay, the first one is VirusTotal.com. VirusTotal.com has been running probably for more than 10 years, and it is a website which is going to have different antivirus software. So basically, you just upload any malicious piece of malware, and it's going to tell you if it is detected or not by those different antivirus products. But it's also very useful because it has a service which is called Hunting or Intelligence, which basically you pay them so that you can be able to search for samples. You can even download it from their database so that you can always try to hunt based on Yara rules. We're going to talk about what is that Yara rule term. Okay, so VirusTotal, it is a really good source of information. It was acquired by Google, which is not the best thing, but anyways. And at the end of the day, they will provide you with an API so that you as a developer can even automate the download and searching for samples in that database. Okay? Underground hacking forums. That's another place where you can go and try to grab malicious piece of malware. Okay? Underground hacking forums is not easy and it is risky also. We're going to talk about why it can be risky and what would be the steps that you need to follow if you want to go to those hacking forums. Deep web, which are hidden sites, normally via Tor is not the only option, but it is a way to search in internet. But the deep web is called that way because it's not indexed by the normal search engines, and therefore you are not going to find those different sites. You need to follow a different route in order to find those sites. We're going to talk about deep web also, which is a place where you can also find real hackers selling exploits or malware. Incident response engagements. If you work for a company which do consultancy for different companies, it's very common that they go into the compromised systems, grab DLLs, grab executables that they don't know what it is. They can send it back to the team, and this is another source for you to have information about a piece of malware. It's another way to hunt. It's not exactly hunting, but it's definitely another way to gather malicious samples. Okay, honeypots. Honeypots traditionally was, or it is actually, as different servers which are vulnerable. Basically, you make those servers vulnerable in internet to attract attackers. The attackers are gonna break into your server. They will think it's actually a real corporate organization, and then that way you can monitor their actions. You can learn what they are doing. That's not the intention here, but what we can do with honeypots is we can get that honeypot, put some different ports. For example, if it is a botnet or any malware that connects to a specific port in order to infect the systems, we can wait in that specific port for the malware to connect, grab the sample, and then be able to start analyzing. So we can also use honeypots to gather information or malicious samples from internet. OSINT, which is called open source intelligence, is a very well-known nowadays term, which basically means that you can grab information from different available sources in internet. Okay, we're gonna see some examples. Okay, so that was hunting. So the next phase is features extraction. Okay, so you know that now we have all different samples thanks to our hunting strategy. We have all those samples, so what do we need to do with them? The first step is features extraction. So that means that you need, the goal of feature extraction is to identify unique static features in the binaries that help to classify them into a specific malicious group. Okay, so we're gonna get static features which can help us to say, okay, based on these features, belongs to this specific malware group. But what are those features? Okay, so the first one is the timestamp. Every Windows binary has a timestamp, which means the date that it was compiled. Okay, that can be helpful for us to know when the malware was created. And that is also very helpful to know, like, if this specific piece of malware was created since 2008, that can give you a clue that this specific organized crime is running since 2008. Okay, normally the attackers doesn't change the timestamp. They can change it all the time if they want, but it is a good way to know when these specific operations start running. And it is a specific feature that you can extract static. What I mean by static is that you don't need to run the malware, you just need to grab it by parsing the executable. Okay? Digital certificates signing malware. That's another very common feature. Normally, a digital certificate can help you to validate that a specific piece of code is coming from a trustworthy company. Like Microsoft, for example, Microsoft, they sign their drivers so that we are using it, we know it is a trust and legitimate binary. But the malware authors, they also use these digital certificates either by stealing those certificates so that they can steal it from the creators and sign malware so that when the antivirus or security solutions check the binary and realize it comes with a valid certificate, they won't detect it as malicious. They will think, oh, this is Microsoft binary, so it is not malicious. So I won't detect it. That's one option. A second option is they can also use self-signed certificates, which means it is not validated by a third party, but also can be enough to bypass detection. Or they can use certificates which are already expired and therefore use it to embed it in the binary. All those different ways to do it can help us to extract that specific feature, because we can go and check all the different binaries signed by that specific certificate, and we can get a lot of samples from it. And of course, can help us to classify them. EXIF metadata is basically all the metadata from different files. Can be an executable, can be a DLL, can be a Word document, a PDF. All those different files have metadata, like authors. Sometimes, like RTF exploits, they use the author name, and we can use that author name to classify them. Language also, from Russia, China, MIME types, images, Word documents, all those different features, we can extract them and again, can help us to start profiling the malicious samples. Import table hash. This is very well known. It was created by Mendiant, which is a very respected company. They used to have a lot of engagements related to compromised companies, and they created this concept of import hash. Okay, so basically the import hash is just, as you might remember, every single executable has an import table, which I'm going to give you an example in the next course. And those different import table is basically all the DLLs being used by the binary. Okay, they grab that list of DLLs and count them, and also take care of the order as they appear in the source code, and then they create a hash of it. That is enough to be able to classify malware. It's not obviously a silver bullet, can have FPs, but it's really useful for classification. Now, the second one is SSDeep. It is a concept also known as fuzzy hash. It is basically able to extract sequence of bytes in the same order from binaries. And that specific sequence of bytes are going to be used as a hash in order to detect samples that can be similar. All these things, as you know, is extracting features to be able to classify the malware. Strings. You can run strings, which is a tool. So basically get human readable strings from binaries or any document. And those strings sometimes can have CNC or C2 IPs, which is the malicious server from the attackers. Can have mutex, which is a specific name assigned by the malware author so that they can avoid reinfecting machines. But it is also a well-known feature that we can extract the mutex. PDB path, which is basically the directory where that binary was compiled. Custom messages like, oh, I cannot connect to this specific server. So sometimes attackers put specific custom error messages that can also help us to identify specific samples. Okay, so that's features, that's static. And now let's talk about behavior extraction. Okay, so we know that we hunt the different samples, we extract the features statically, help us to classify them. Now that we have a specific classification, we also need to add to that specific group or cluster behavior, which can also segregate more between groups, because we can have a group with all those different features, static features related, but the behavior can help us to segregate it more. Okay, so what is the goal of behavior extraction? Is to identify unique dynamic features in the binaries that help to classify them into a specific malicious group. Okay, normally this is detected by running the malware in sandboxes. If you took the malicious software defender course, you learn about how to run sandbox how to run samples in sandbox, how to extract the features. So basically, that's important. And here it's very important to know that, because you as a threat intelligence researcher, you don't need to know reversing. Basically, you just need to know all those different techniques to gather information in order to cluster. Probably you will need reversing. You can team up with a reverser to give you more details, but most of the time you can do a really good job without even starting taking help from reverse engineers. Okay, So you can also get behavior not only by running in the sandbox, because normally the sandbox is going to tell you, okay, it is calling this API or this other API, and that can help you to understand the behavior. We're going to see some examples. But also, you can extract dumps from memory, which can also give us a lot of information while running. Okay? Most of the malware will decrypt in memory, and from there we can get really good features. Like, for example, the RATs, remote administration tools, they are very common to have a configuration file. However, that configuration file normally is decrypted in memory. If we go and dump the memory, we can get those configuration files and easily detect a specific RAT. Capturing malicious events, as I said, while running the malware. For example, there are many malicious events. Those malicious events are going to help us to classify that specific family. For example, if it is creating a file in suspicious location, might be something that it is called a dropper. A dropper is just going to drop a binary into disk. That is a behavior. Injecting into other processes. Maybe this guy is just going to run, check the processes running in the system, and inject into them. Download and execute from the internet. That's also called downloaders. They are just going to go to the malicious IP, get the binary, and run it in the system. It's the only thing they do, but they are called downloaders. That can be the purpose. You remember in an attack flow, there are many different phases, right? And if the more they segregate the attack, the more difficult to cut them. Keystroke interception also, it is another technique which can also be done by the malware. It's very common for banking Trojans so that they can steal information as you type in the keyword. Anti-VM, anti-debugging checks also, malware will check if it is not being debugged or analyzed by a malware researcher. And you can get all those features too. Delay techniques, very common to bypass sandbox. Basically, the malware is going to say, I'm going to do some checks, and if I detect that I am being run in a sandbox, then I'm going to wait. I'm not going to run. And normally the sandbox has a timeout, and eventually will just stop running, and therefore it's not going to detect anything. That's the reason of those sleep calls. Persistence, how the malware will stay in the system after a reboot. Normally through registry keys, which is very common, adding it as a service, or adding it as a scale task. There are many ways that the malware can add persistence. Features that we can use to categorize or classify our samples. Okay, a little bit of more events, malicious events. Desktop locked is very common from ransom lock. Ransom lock is gonna just lock your desktop so that you cannot do anything until you pay a ransom. That's the way it calls ransom lock. So you can see APIs doing these specific actions. Multiple files override might be a file infector, which normally is going to scan the whole system and then override the system binaries or any other documents with malicious code, and those are normally called file infectors. Dumping hashes from memory. There might be a malicious event that it is just trying to get the SAM database, which are the Windows account hashes from memory. It's another behavior. Okay, so now let's talk about a different strategy also, about passive DNS. Passive DNS, I'm going to give you more details in the next course, but so far, it will help us to know, for example, what DNS names have pointed to a specific IP. So let's say that right now you detected a malware connecting to a specific domain, but by querying the DNSDB passive DNS, you can know in history, the last 5 years, for example, that specific domain, where are the other IPs it is pointing to. That can help you to know the activities and how far this specific organized crime has been running, or also to confirm if it is indeed malicious. Also, in the opposite side, what IPs have pointed to this DNS name? Okay, so you can have the same domain but different IPs across the years. Let's talk about clustering and correlation. That's the next step after we extract all those features, after you extract the behavior. So once you have everything, you need to cluster it, which means you need to store it in an intelligent way so that those are classified per all those different features that we extracted and the behavior. After that, you need to correlate so that all that information needs to be connected to make sense, okay? So the goal of clustering and correlation is to classify malware based on features and behavior extracted and correlate the information to understand the attack flow, the full picture. So we have clustering, which are basically nodes that we're going to call nodes, which are those different specific objects identified with a specific feature and a specific behavior. Okay, and those different objects creates the cluster, which are based on features, as I said, the timestamp, the imp hash, SSD, digital certificates, all those different features, static features can help us to classify it. Then we have properties. All the behavior that we detected, as you remember, keylogger, downloader, dropper, those are properties for that specific node, but that will help us also, as I said, to segregate. We have a group which has these specific features, but also is a downloader or a backdoor. That can help us to add more context into that specific group, or even segregate more than the clusters. Correlation. Once we have the information, we need to exploit it. How? Via what it is called GraphDB. Basically, you don't want to use a relational database because what you want to know is how you can connect the dots. And relational databases are not designed to do that. That's why it's very recommended to use GraphDB. It is a NoSQL database, and it is just a collection of nodes and hashes. Let me show you a picture. It's basically, as I said, it's just connection between nodes, relationships, and properties. All the different things that we just found, that we just collect, can be interconnected, okay? We're gonna see some examples. And here is the correlation, okay? So basically, this is the final goal, to have from, as you can see at the middle, that specific MD5, which if you go and start analyzing it, you extract features, you extract behaviors, you will realize that, okay, this specific binary probably has a specific key, and then it will drop into specific systems, and then will connect on specific IPs. You know, the full picture of the attack is represented. This is from CrowdStrike that they documented from a specific organized crime organization, but this is exactly what we need to get as a threat intelligence researchers. Okay, so now you have the features, you have the behavior, you put it in a cluster, you put the properties of those different nodes, you classify them. So who is behind? At the end of the day, that's the most important goal, okay? To locate the threat actors behind the malicious clusters identified. So for example, you need to answer these questions. Where are they located? Which country? Who is sponsoring them? Sometimes it's nation state, can be Russia government, China government. What sectors of our industry are they targeting? Okay, so normally the groups are gonna focus on a specific sector, financial institutions, banks, or probably they're just focusing on, you know, nuclear plants. And that also helps you to categorize the threat actors. C2 infrastructure, where are they located? What are the ports being open? What is the operating system running? All those details help you to understand the C2 infrastructure. Tactics, techniques, and procedures. When you are a threat intelligence researcher, you will be always dealing with TTPs, which means how do they get into the system, the techniques being used, the procedures. All those different skills are going to define that specific group. And here probably is where you might need help from a reverse engineer, because you will exactly need to know, like, what is the encryption algorithm being used in order to decode the binary in memory. Or for example, where is the malicious code injected? It is in memory, or it is coming from the resources of the binary. All those details. How do you get persistence into the system via registry key, COM objects hijacking, different techniques. That's where reverse engineers can help the threat intelligence researcher. Okay, so you can also know in the initial compromise how they get into the system. Can be a spear phishing attack, can be just Facebook links, fooling people to download malware. That also defines that specific group. Privilege escalation. How do they elevate privilege once they are inside the network? There are different techniques. As I said, persistence. Lateral movement, very important. How do they spread in the network? Different groups use different techniques. It's very important to define that specific group. Exfiltration strategy. How do they steal the information? Is it via HTTP post request? Is via a raw socket? Is via a proxy? How do they do it? And what information they are extracting? What is the format? Okay, so if no threat actor can be identified, the whole threat intelligence effort is useless. At the end of the day, okay, you found malware, you found features, you extract them, you cluster them, and even you detect them, but if you don't know who is behind, you cannot take down the organized crime. Okay, so you identify the creators, you identify the organized crime, it's time to track them, to know what they are doing, what they are up to. Okay, there are different ways to do it. The goal, as I said, is to anticipate new attacks and identify new variants proactively. Okay, how you can do that? We talk about passive DNS. They can switch to a new domain or pointing a domain to a new IP address, and by querying the passive DNS database, you can know those changes. Okay, and right away you can see, okay, now it is pointing to a new domain, or the same domain is pointing to a new IP address. Internet port scan, that's a risky but very interesting approach. So basically, if you know that the C2 is listening into a specific port or different ports, you can go and scan internet and find those C2's infrastructure. I'm going to give you some examples. Lookups. So you have the features, you have the behavior, you can create Jara rules or Snort rules to try and hunt them, to go to VirusTotal or to go to your own database in your company with hundreds of thousands of samples and try to search for those features to see if you can find more. You can put even a VirusTotal service, you can put a Jara rule saying when you match this specific string or this specific API or this specific sequence of bytes, send me an email. Okay? Imp hash, SSDIP hash, very important here also. As you remember, import hash and SSDIP properties, they can also define similarity between samples, and then you can use it to track and find more samples. OSINT, open source intelligence. With that information, you can now go and check the IP of the C2, and probably you might find email addresses associated, new domains created, many different information. Gang infiltration into hacking forums. Obviously, you can keep tracking them if you are still in the hacking forum and they are discussing the new release of the tool. If you are there watching them, you can get that first-hand information. But that normally is done by FBI, so I'm going to talk about risk in the next course. Actually, in the course related to hunting. Okay, so we are here in the final step, which is taking down. We understood everything about the group. We even know that it is a APT group X5 that we define that name. We are tracking them, and probably it's time to take him down. In order to take him down, we need to join effort with a law enforcement corporation. Can be Interpol, Europol, FBI, depends on the country, but it's not that easy. But it is what should be expected at the end of this whole effort. As I said, the goal is to dismantle organized crime operations. Take down these guys, even physically arrest them to stop operations, period. Okay? One of the really cool techniques is called sinkhole. We're going to talk about that in detail, but it's basically you're going to take over the C2 infrastructure in a different approaches so that everything, all the different hosts infected are going to point to you, not to the bad guys, and you're redirected to your place. Or you can even take over the whole server. There are different approaches that we're going to talk about, but at the end of the day, you are just stopping their operations. Okay? We can do man-in-the-middle attacks, which basically means I will forward all the traffic to my box and then forward it to the bad guys so that they think they are still operating, but at the same time we are monitoring every single action and updates. And we don't let victims to get reinfected. Hacking forums is very common to take them down. There are some examples like the dark code case that was in specific hacking forum, very famous, sending exploits. It was took down, but that's very common and don't be a law enforcement. These takedowns requires countrywide collaboration sometimes. Let's say that there is an IP detected being attacked from China. It's not easy to just ask China, hey guys, could you please go to the ISP or hosting provider and take them down, please? It's not going to happen. Same from Russia. So sometimes it's not possible to do that. Okay. So finally, let's talk about the summary. So we talk about all the different phases of the threat intelligence effort so that you can understand the big picture of these really awesome skills. We talk about the final goal, which is to track down the threat actors behind and stop them, which is the final goal. And we said that this whole effort requires country collaboration. Finally, the physical arrest. At the end of the day, you can take down the IP, okay? But if you take down the IP, probably the operations of that specific server is going to be completed. But the bad guys can create another server with a different IP, get more malware, and start spreading it, start infecting victims. Physical arrest via law enforcement or different international police, they can help us to stop and go and physically put them guys into jail. Okay, that's all. Hope you enjoyed.